In this video, we have another limit to evaluate using L'Hopital's rule. So notice here we have the limit as x goes to 0 from the negative side, or the left side, of 1 minus e to the x to the x power. Now if I just plug it in, 0, I got e to the 0 is 1, 1 minus 1 is 0, and then the exponent is x. So basically for this one I have 0 to the 0 power, which is one of those indeterminate forms. So here's a statement that we've been using. L'Hopital's rule states if the limit of f of x over g of x, and the limit could go to any value, infinity, negative infinity, you plug it in, you get one of these forms. 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, 0 to the 0, 1 to the infinity power, infinity to the 0. Those are all indeterminate forms. Anyway, it states that if you plug it in and you get one of these forms, you can find the limit, or it tells you that the limit, whether it's infinite or going to some constant, if you take the derivative of the numerator over the derivative of the denominator, if this limit exists, then that's going to be the answer to the given limit, f of x over g of x, as x goes to whatever, whether it's a certain value or infinity or minus infinity. Now you do want it in this form, so if the given expression f of x over g of x is not in this form, if it's a difference or sum, rewrite it so it's in this form and then look at see what happens. So for this one here, I wanted it as a fraction. Once you have the form 0 over 0 or infinity minus infinity, make sure it's in fraction form. This one is not. So what I'm going to do is let y, or some other variable, equal to this limit. And then I'm going to take the natural log of both sides. 0 to the 0, indeterminate, but I want it as a fraction. So I'll take the natural log of both sides here, natural log here, and I have this expression to the x power. I take the log of that. This will be the limit as x goes to 0 from the left side. So because I'm taking the natural log here, properties of logs allow me to bring this power to the front. So that would be here, x. And then at the same time then, I can rewrite this, 1 minus e to the x. The x now comes over here, properties of logs. Then I divide through by x, and this becomes 1 over x then. Now I have it as a fraction. And I've got the log, natural log of all of this. And I can put the natural log here. It can come inside the limit. Now I got this. So 1 over x approaching 0 from the negative side, this is going to go to minus infinity. This will get close to 1. This will be close to log of 0, which is undefined. But if you plug in values, this is going to take the form now of negative infinity over 1 over 0 from the left. Also will approach negative infinity. You can plug in some values to justify that, but this is what we have. Now, because I have it as a fraction now, when I have the form negative infinity over negative infinity, that's one of those indeterminate forms. Natural log of y equals to this. Now I can take the derivative, and I'm still going to have the limit as x goes to 0 from the negative side. Now I take the derivative. Natural log will be 1 minus e to the x, and the derivative of this will be 1 minus e to the x in the denominator, and then the derivative goes in the numerator. This will be minus e to the x. The derivative of 1 is 0, and the derivative of minus e to the x is minus e to the x. The derivative of the denominator, 1 over x, is minus 1 over x squared. You look at this as 1 over x, that's x to the minus 1. Take the derivative of that, get the minus 1 over x squared. And then this is equal to the limit. I'm just going to simplify. Took the derivative of the numerator, the denominator, and of course I have the limit as x go to 0 from the left. Going to multiply the numerator and the denominator by x squared. At the bottom, it'll just give me a negative. You can cancel the negatives here. So this is just giving me an x squared e to the x. Again, negatives here cancel, and then I'm multiplying by x squared. So it's 1 here. So I'm going to get this. Separate it there. So multiplying, the negatives cancel, multiply by x squared. This becomes a 1. So all I have left then is e to the x times the x squared here over 1 minus e to the x. Now let's look at it again. Limit as x goes to 0 from the left. So let's just plug in 0 there. Here, it's going to give me a 1. That's be 0. 0 here is 1. 1 minus 1 is 0. So I get the form 0 over 0. Still indeterminate. So we take the derivative again. We keep applying L'Hospital's rule. As long as you have it in one of those forms, you can keep applying L'Hospital's rule. So I take the derivative again. I have to use the product rule here. The derivative of the numerator, x squared times the derivative of e to the x, that's e to the x, and then go back the other way, plus e to the x times the derivative of x squared. This is 2x then. So x squared e to the x plus 2x e to the x, and the derivative of the denominator, derivative of 1 is 0, and for minus e to the x, I get minus e to the x. Again, before I do anything, I simplify this. So this would be limit. X goes to 0 from the left side, or the negative side. You notice that e to the x, e to the x, e to the x in the bottom. So those will cancel, and they'll leave me with minus x squared minus 2x. So again, all I'm doing here is dividing through by minus e to the x. E to the x cancels, and those terms on top become negative now. So I get a negative x squared minus 2x. So now, let's just plug in. As x goes to 0 from the left, so this gets close to 0. So this will be 0. X gets close to 0 from the left side. X gives me 0. 0 minus 0. This will be 0. So I get a limit of 0. So what do we have? Follow the steps here. ln of x equals, we did these calculations, we got this. So we get then ln of y has to equal to 0. Now let's simplify this further. The base here for ln is e. So applying your definition of log, in this case natural log, y has to equal to this base, which is e, taken to the 0 power. That's equal to 1. So y is equal to 1. But what is y? Y is this. Let me take this off here then. Now I know the value of y. And y is this limit here. So using L'Hospital's rule and going through all this calculation here, we get the answer. The limit as x goes to 0 from the left side of this expression, 1 minus e to the x is equal to 1. Now we'll put links on the description of the video to the related videos dealing with L'Hospital's rule in case you missed those. Thanks for watching. We'll see you next time.